welcome everyone to another Pionix webinar. This time about from lab to field with zero blind spots. It's all about how our new cloud offering can help you to boost charger development and charger maintenance, everything based on the software-defined charging paradigm. So quick recap, because maybe not everyone knows us already. We are a startup from Southwest Germany, started 2021. We are the initiator of the LF Energy Everest open source project in 2022. We have around 30 people, I think meanwhile a bit more, headquartered in the Karlsruhe region, and we do a lot of things. But before I go to that, everything we do is based on the Everest open source project. So this is really core to our DNA. And what is this? It's basically a charging station firmware stack. It's super modular, super adjustable to everything from simple AC home chargers to public DC fast chargers. It can speak a lot of the hardware driver internally. It can speak to all the surrounding, from all kinds of vehicle protocols to home energy management systems, to remote energy entities, to CPMS systems, to payment terminals, the human, and this list is extended all the time. For example, I think we just added EEBUS. We're already quite good on OCPP. I think so. As far as we know, we have the most feature complete stack out there, and is runs on every Linux system, costs nothing, is hosted by the Linux Foundation Energy, so non-profit. It's in a very industry license, friendly license, Apache 2.0 license. I think meanwhile we have a few 100,000 charging stations out there by a few dozen different vendors, and this has really a stellar climb over the last years. And we as Pionix, we offer different services and products around this. First, there is our new cloud offering, which we'll present today. So we'll not say too much about this here. We had another cloud offering already launched in the last webinar 3 months ago, which is a virtual charger park. We'll have a few words about that some slides later, but if you want to learn more details, there's also the webinar, which you can look. And then we do services around Everest. So if anyone needs help using Everest, changing Everest, or want to find out about how to build EV charging in general or test EV chargers, please ping us. And we're also having hardware items, which makes it easier to build an Everest-based charger. So basically, it's a companion microcontroller next to your Linux system, which takes care of the low-level stuff. But that's not the topic of today. Today, we talk about the development processes. So maybe you can find yourself in this. If you develop a charger, first it works on your desk, then you deploy it in the lab, maybe deploy it in front of the building so your colleagues can charge at work with your prototype chargers, maybe deploy it at your home, maybe at your boss's home. Then you get a call. Something doesn't work. What are you doing? You could try to figure out which charger is it, who deployed it there, what's going on. You could try to find the IP address, the VPN, the passwords, or you can just drive over there. End of the day, it will be really messy, and this entire testing setup is not easy to scale well. And this is what we want to change. But before also going into detail here, let's widen the view a bit. Also, what Pionix is doing. So it's really about this entire development processes, from what we do, starting on exploration requirements designs, helping with customizing designs, or basically that's something you or we have to do. You have to implement things on your hardware. You have to test something before it goes to production. You have to ramp up the production. You have to offer maintenance to your CPO customers. You have to do compliance testing. And what we want to talk about with the Pionix Cloud is really the right 70% of this timeline. So the entire flow from having the first code until the last charger had end of life out there in the field. And Pionix Cloud is all about offering services here from a more technical engineering perspective. And we split that into two halves. The first half is the Charger Developer Cloud, CDC. And it's really there for helping you to assisting you while you're developing the charger, and then out there in the field when you're maintaining that. That will be our next webinar, actually, somewhere Q4, when we're launching the maintenance cloud. But feature-wise, there's a lot of similarities. So in a way, we talked a bit today about both, but the main focus is on the Developer Cloud. And if you look on the Pionix offering, so this is not a CPMS. If you look on the ecosystem, so charging on the right with the charging station, you have a lot of electronics inside and plugs and cable and maybe a Pionix charge bridge or something else. You might have an Everest deck in your charging station or something else. Then it's connected with OCAP with a typical backend system, and the backend system is then typically only visible to the CPO. The charger vendor has a blind spot. There's no direct connection typically. What we offer with our cloud solutions here is breaking this connection. As particular, the Charger Developer Cloud runs in the cloud, how it's called, but it also has an offline, let's say, edge component. We'll call it the Cloud Connector. We'll also go to that in the details later on, but it's a local client which connects to whatever firmware running on your charger, for example, Everest, but it's also very flexible beyond, and can really extract data for monitoring, for helping you to testing, and helping you to maintain those chargers. And to give you a quick spec sheet, what it can do in detail, and this is basically also the chapters of this webinar. We'll start a bit with the dashboarding. So what can you see about your chargers in the field? We have a lot about telemetry, digging into those chargers, try to find out what's going on or what failed and why, from, let's say, simple telemetry to really to full protocol recordings. We can give you remote access. All of that optional. We have firmware management, over-the-air update management, particular Canary updates. We'll talk about that. We'll talk about how the Cloud Connector works, so in case you want to modify that or you want to try it out. And we also have a few enterprise features. We don't go into so much detail here, but this is really enterprise ready in terms of control, auditability, API access. So, but now I would love to hand over to Lukas, who is the lead engineer on this project, and he would love to dive you through the features.
Let's do that. Yeah, we built a cloud connector for you, which is in the end a separate process which runs next to Everest. So it's not managed by Everest, because when Everest is broken, you still want to be able to fix it. So we did that, and we know as well, because the Everest community likes it, you like modular systems, so we built it very modular as well. Every charger looks different in the end, and consists of different things. You want to have different capabilities on that charger, so you can basically mix and match different plugins depending on what your use case is. We have a core which is connected to our cloud via MQTT, and we have the Everest plugin, for example, which connects to Everest and gets all kinds of Everest data out of it. And because it's realized as a separate module, you can even retrofit it if you still have some kind of legacy chargers which are not yet on Everest. Then you can even integrate that yourself and use it for those things. But more about that later. We already made a webinar recently about the virtual charger parks, and I will use them today as well to show you what you can do with the cloud, just because it's easy to try everything out and you can do it yourself as well. You can obviously, in a usual use case, you would use your actual own hardware, and I will also show you at the end how you integrate that. Let's see what we can do with our charger. Here's our charger, no charging session yet. Let's change that. Let's open it in our virtual charger parks, which you have maybe already seen in the last webinar. And let's start a charging session, plug in a car, swipe an RFID card, and Everest is charging. And the cloud connector is already connected in this case. And let's hop back into our CDC. And we see first telemetry is being reported already. We are seeing stuff like RAM usage, CPU usage, and all kinds of other numeric values. And we see our charging session. And on that charging session, we can see the individual session events of Everest, of the EVSE manager, and we can see the details of those as well. We can see the telemetry information during a charging session, so scope to that time frame. And we can also request stuff like the PCAP file or the event log of Everest, let it upload those to the cloud, and then we can analyze further if we saw a weird charging session. And we can see the different modules of Everest, and we can see the communication between them by subscribing to it. And now the charger is forwarding the communication between those two modules to us in the cloud, and we can see exactly what they are talking to each other. So we can go in here, copy as well the MQTT path. So we are seeing really the internals of Everest here, the messages, the history, and so on. And we have also a generic way to subscribe on generic MQTT topics. So if you put them on the MQTT broker there, you can do that as well. See all the communication of Everest happening here now. What we can also do is we can request an SSH connection link. And I will later show you a bit more in detail on how the remote SSH stuff is working. Let's first explain a bit more about how the whole telemetry stuff is working. In OCPP, there's also this device model. We basically took that, got inspired by that, did it pretty similar. And you can define a hierarchy of your components, different parts, how your charger is built, so that you in the end basically get a digital twin of it. At the leaves in the end, you can define telemetries, and they then represent some kind of telemetry value which you want to have reported over time. And we can now look at another video of how we can customize our telemetry a bit. We can create different dashboards to look on our telemetry. And we can even upload a 3D model of our charger and annotate certain components with those telemetry values we have, so that we can even on the 3D graphic find those values again and basically do stuff like click on a cable and you can see the exact voltage. We can change our dashboard, adapt it to whatever we want to show now, and we can also later share these dashboards with different people so that we can give them a dedicated dashboard for what they want. Let's save this dashboard. And yeah, now you can see we have adapted that. And now we want to add some more telemetry, which we don't have yet. We have previously seen our MQTT Explorer. Let's look into some internals of Everest and get them out there. Even though we would recommend you usually to use the stable APIs. If you are debugging something for not available, then you can do that as well. And now we started recording here, and now the charger is actually sending this telemetry information to the cloud. And you can also permanently do that by adding the following YAML there to the Cloud Connector config, which I will show later. Now we have a new telemetry, which we are being reported, which we can see here. We can add it to our dashboard. And we see it's reporting quite a lot of telemetry here. So if we are under constrained data usage environments, where we are connected via LTE, for example, we might want to reduce this, and we can define monitors on individual telemetries, which define how often you want to have those things reported, for example, on a minimum interval or with an upper threshold. So when the grid is over 60 Hertz, you probably want to have a warning. That's more than usual. You can apply that, and now the charger is not reporting as many values anymore, but just when it's needed. Another thing we are doing is we are running analyzers on all kinds of things. For example, on charging sessions, we already have a first few charging session analyzers in place, and we are continuously expanding them with further analyzers on those charging sessions. And there we are flagging sessions with known problems we have typically seen in the field. And in this example, it was a newer charging session was already started, but no explicit end event was received from the charger. So there was probably something wrong with this session. We are flagging it here. And then you can diagnose it further. And now you have a broken session. Pionix is great at helping people with fixing stuff on their Everest-based chargers. So we also have a way to collaborate on your chargers and also on stuff like logs and so on. So what you can do is you can share access, in this case, to the specific charging session. You could then share this access even with us, and then we would have access to this specific charging session and could help you with diagnosing that. So we have we call it here like collaborate like Google Docs for your charger. You know it there. You can collaborate with people from different companies easily, invite people and so on. And we did the same thing for your chargers as well. If you have a lab charger you want to collaborate with, just invite a colleague, even if you have a contractor and don't want to give them access to all of your chargers, but just the single one. All right, we looked a bit about looking at stuff. Now let's look about changing stuff to fix it. We have remote SSH as an optional thing you can enable on your charger via the remote SSH plugin. And we thought you probably don't want to have an SSH port always open. So what you can do, or typical situation, you have your charger behind some kind of net or firewall or whatever, and you want to connect to it remotely from home office, for example, when you have a lab charger. And what we do here is the charger is connected to our cloud via MQTT. We can send the charger basically a request to send us a unique connection link to connect to it and our public key. And it will send us back a unique key, which we can use to connect to it via a relay. And then the charger validates our public key additionally, and we can connect to it via the relay. And through that, even without a constantly exposed SSH port and behind firewalls and whatever, we can easily reach it and do stuff with it and have it all audited in the audit log. Then what we can do is we can also change the Everest config. So we have a simple Everest config editor here. We can, for example, change stuff, save it, and also switch to other configs if we have multiple configs on our lab charger. That's a thing we typically have. And then we can switch between them. We can restart Everest, or we can even restart the whole charger as well remotely. Then developers always like terminals, so we thought let's give them a little command line interface, the Pionix Cloud Command Line CLI, PC CLI, which you can use to upload stuff like firmware bundles, for example. If you are building Yocto images on a build server, that's pretty nice to have. Then you can upload them directly to Pionix Cloud, and they are being installed on your charger automatically then, or manually, depending on how you configured it. And you also have interactive mode you can use. And in this one, you have a simple terminal UI, which basically does the most basic functionality you usually need via the web interface, even in your terminal, so that you don't even have to open the web interface. And I just showed you there that you can remote SSH to it via that, for example. All right, we also have the ability to update your firmware. In our case, we have different hardware we are shipping. For example, the belay box, the micro megawatt charger, and all kinds of other things. And we create individual firmware for each of those. Each of those firmwares we call firmware editions. And a firmware edition can have individual release channels, depending on what the development workflow for that firmware is. When you now set up your chargers, you can your charger basically reports its own firmware edition so that you cannot accidentally install a firmware image on the wrong charger. And now you can make your charger follow a certain release channel. For example, we have a few chargers in our parking lot which are always tracking the development branch, so that when we are pushing new commits onto our development branch, they are always updated with that. And if development is broken, people will notice in the parking lot already. And other chargers can also be pinned to specific versions if you want that, then they are not automatically updated. How would that look like in a typical development process? A firmware bundle starts out, for example, in development. And that's only installed on a few chargers. And now we are gaining more confidence in this specific firmware bundle because it was running quite fine in our parking lot for quite some time. And we push it a bit further to beta, for example. Then more chargers are automatically updated because they are following this additional release channel. And if we then are really satisfied with it, we can even push it out further, have more chargers following it. But this then goes a bit in the area of CMC, where you are installing it on chargers in the fleet. But you can see all of these things are integrated with each other so that you can really have a development workflow which spans your lab until the field in the end. Let's look at how this looks in the web interface. So I have two firmware editions here. That's one for our micro-megawatt charger. And as you can see, our CI pipeline is constantly automatically uploading those firmware bundles. And the PC CLI, because it's running in the CI environment, is also annotating the commit messages to it. You can download it here, set it up. It's all described there by an API key you can create. And you can also manually upload those bundles, of course, if you want to. But then you have all the Git information related to it. Let's take our example charger here, give it a new firmware bundle and apply that. And in this case, manually update it to this explicit bundle. And we can see an over-the-air update was started. It's also appearing in the audit log of that charger. So you can see the full history of who did what with this charger when. In there. And you can see the update is running. And another charger which reported the running firmware. Here you can also see, okay, it's all linked together so that you can see this charger is running this specific firmware from this specific pipeline run, so that you can trace back bugs easily. Let's look back again at our architecture slide here. As I've already said, it all consists of individual components you can put together. And pretty similar as Everest, it's all configured in a single YAML file. This single YAML file contains everything you need to set up the cloud connector on your charger. And I will later show you how you build that. It is then installed by either the PC installer or our Yocto layer. So we have an installer which basically runs on the charger. It automatically detects the current architecture. And with a single call to bash command, you can install it on any lab charger you have laying around. Even if you have some old firmware image on there, it doesn't really matter. It just needs to be Linux and has to have some kind of writable directory anywhere. So that you can even do the installation into /tmp. And in /tmp, when you restart the charger, the cloud connection is gone again. That works as well. But if you want to have it permanently as part of your images, you can use our Yocto layer. It just uses the same config file, and from that, it sets up stuff like a specific user for the cloud connector, a systemd service, all those kind of things you want, and then it's part of your charger image. Let's create such a cloud connector config. We added a little wizard for you in the cloud. You can just go on cloud connector config in the left sidebar, create a new cloud connector config, and use our wizard. And this wizard then allows you to define a way to derive the identity of the charger. For example, you can use the MAC address of a network interface, which we will use for this example. And you can select the version number of the cloud connector you want, stable. In this case, we just use the latest stable one. And you can decide how you want to have the persistence handled via systemd, locally, or like that as well, temporarily, so that it's only installed in /tmp. Then we can set a model name and a manufacturer name for our device model. And we can select what functionality we want by selecting different plugins. A few are pre-selected, which usually makes sense during development. And this charger is based on Rauch, so we will just use the Rauch updater plugin as well. We can select where we have our Everest config directory stored and the zoom link to our currently active config for config switching. Now the config is created. We can configure a lot of more detailed stuff in there as well. It's a YAML file as well, so you can also do it directly as YAML there as well, depending on what you prefer. And we can then use the same YAML file as input for our Yocto layer. Or we can go in our charger list again, press on enroll charger, and select it here. And we get a curl to bash command generated, which automatically downloads this config file and installs it on our charger. Now, when you want to try that out really easily, you can also just press this little button, Quick Connect to VCP, and it spins up a virtual charger in the cloud for you, which is running Everest. And it does the whole installation process we have just shown there in a Docker container. And it's a great way to test stuff out before you run it on your own charger hardware. But obviously, you have seen via this wizard, it's actually pretty easy to integrate it and should be pretty quick to get started.
Yeah, thank you, Lukas, for the introduction and a lot of the technical insights behind and why things are built this way and what is the logic. I would love to give our audience also an outlook of what comes next, but let's first recap where we stand. So this was all about the Charger Developer Cloud, Pionix CDC. Also center of disease control if you want. And so we want to help you to tidy out your chargers during development. So it gives you this unified development access. It gives you remote secure access, gives you all the firmware update and orchestration behind that. Gives you the remote resolution and diagnostic capabilities, and you really can scale this across a bigger fleet if you want. So the benefits, what's creating for you, you have basically losing any friction development process. You're gaining a lot of speed or velocity when you automatically, let's say, tracking your main development branch. And when you just do a code commit, your CI/CD compiles something, loads it up, and some minutes later, it's installed on your chargers in front of your building. And since it then also reports back telemetry, you basically see automatically, if you want, if something goes well or not, at latest when the next one plugs a car, or you actually start some trials. Yeah, you basically can lose a lot of anxiety on firmware development with this canary update, so you can stage this rollout. So you can start with your own charger, your boss is maybe number 3 in the rollout step, and then after a while you can add 100, 1,000, 10,000, 100,000 chargers. So you don't do everything at once, and it gives you a lot of safety nets in between. Yeah, and it erases blind spots, so you can see very detailed what's going out there. So there's no firewall between you and the fleet if you're really unrolling this into the field. Yeah, and it enables you to instantly collaborate between different developers. As Lukas said, in the next releases, we'll have sharing functionality, so you can share log files, share charger access, make it temporarily, if you just need help from someone else. And it doesn't matter to which organization that belongs, as long as you're setting up the right permissions. What we want to build next, later this year, is the Charger Maintenance Cloud. The underlying technology is very similar, or almost the same. It will have different skins on top. It will have different workflows. The problem we want to solve here is asymmetric visibility with typical charge management systems. So as a vendor, normally you're blinded. You don't see what's going on there in the field. So we can solve that. A few big vendors already built that themselves, and we just want to give this power to everyone. And then there's another typical problem that happens way too often. Someone is logged into a bad CPMS and can only get out of that either by collaboration of that bad CPMS, that they are reconfiguring the charger to the new CPMS vendor, or by just driving out there. And by having a secondary channel, you can solve that problem as well. Others try to solve it with OCPP proxies, but then you have the same problem if the proxy goes wild. So this is the idea here. And in terms of benefits, we really reducing the we basically bring the efficiency of diagnostics you typically have in the development lab really to the field when you need it. We're reducing the number of site visits. We enabling your predictive maintenance, optimizing your assets. We can help you with more risk-free software update. And it's really on a need-to-know basis. And if you want, you can even make this totally non-writing on the chargers. And at the end of the day, this reduces downtime and improves security of your charging network. And let me wrap up. So if you want to try that out, Pionix Charger Developer Cloud is free for lab scale use, so let's say around 10 chargers. Just go on cloud.pionix.com and try it out. You have seen you can also try it out virtually with spinning up a virtual charger, or you just get it installed on your physical charger. We're also happy to help you with that. That's basically the next one. If you need help debugging Everest, try out with virtual chargers or with real chargers, the Charger Development Cloud, Charger Maintenance Cloud, just give us a ping. We're here to help. And I want to point out 2 upcoming events. There's one big webinar mid of August, 25th of August, together with Codeco, a big distributor for electronic components. We'll talk about building blocks for software-defined charging, so a bit more down to the hardware. And it's not only Pionix ChargeBridge, it's also some other nice goodies next to it. And how this really accelerates your hardware development. And one other thing which is really, really close to my heart, we realized there's a spot in the conference landscape all over the world. There's trade shows like Power to Drive where you can show your stuff or can visit others who show their stuff. There's conferences like the ICNC in Berlin, the Intercharge Network Conference, where, let's say, business people meet to talk business relationship between different networks and CPOs, CPMSs, and so on. But what's missing is a software developer conference in EV charging. And since we have a so big software developer community around Everest, again, this is way bigger than Pionix because not every one of them, most of them actually, are not yet working with us. We want to bring them together. We want to create a stage for that. That's 7th and 8th of September, directly after ICNC. So if you're already in Europe or in Germany, just stay over the weekend, visit some beautiful old castles, and then swing by with us. We have interesting speakers from companies like Tritium, Zaptec about their journey with Everest. We have people from Charge Cloud and Monta talking about their experiences on backend software development and testing. I think it will be pretty interesting. And if you're then still interested in even more content, we will go next 2 days with Everest Community Hackathon or Everest Maintainer Meeting, really, really deep down on co-coding, having a good time, sharing some pizzas, some mates, and do whatever people want to do. Everyone can suggest content. You will find all details on the-event.tech. And so that's it from my side. Let's start with the Q&A. And I think we already have a few questions here in the tool and in the chat. And I would just start going through that. 1 second. There's some people use the chat, some people use the Q&A tool. I will start with the chat messages. Doesn't firmware management directly compete with firmware management of OpenCVP? Is it more advanced and capable? Yeah, even if it's more advanced and capable, no. So yes, if you are unrolling this to the field with CMC, it could conflict, but 2 things said, not every charger out there is actually having access to CPMS. So, and second, you can disable this feature as well if you're going to the maintenance mode. And third, even if you're unrolling firmware updates through OCPP, you still need a download server where the update is coming from. And you can wire up the CMC with your CPMS. So this can really work in harmony, and it can also work standalone if it has to. Lukas, anything to add?
Yeah. And to add to that, obviously, in your lab, you often have chargers where the OCP is maybe not working because your firmware bundle had something which didn't work. And in that case, you want to have a backup channel for updating there continuously as well. Depending on how the situation is in the field as well. In CMC, we have this sophisticated access control system around everything as well, so that we can do stuff like involve the CPO, have them approve updates before they are run, and stuff like that. So in the field, obviously, you have to find a way to deconflict those two systems, but that depends on the situation you are in, and is all configurable.
Thanks. Next question is a bit in a similar direction. So when we talk about firmware updates, typically it's full system images of the charger. By the way, it's actually pretty safe to this mechanism, because you don't have to trust Pionix with regard to firmware updates at all, since it will be signed by the vendor on the CI/CD pipeline, which is owned by the vendor, and the charger itself will download those bundles and then will check the signatures. So we adjust the transport channel in combination together with OCP, but we're not really involved in the content. So for us, this is a blob. We trigger the charger to download the blob and to do something with the blob. How that works in detail is really up to the firmware. And the security of that is also up to the two endpoints, the charger firmware to validate signatures, and the CI/CD of the vendor to sign them correctly. Lukas, any words for that?
And about different ways to do that, we also have the generic updater, so not only the RAUC updater, which allows you to integrate all kinds of other updating systems you have via hook script. So depending on how your architecture is there, you can probably integrate it.
Yeah, and those firmware updates can be triggered by OCP, and optionally they can also be triggered by the Cloud Connector plugin. Okay, next question is on the Q&A tool. When we have to change to Everest config, can we schedule a time slot so the change will be applied at night? I think this is on Lukas.
Currently, you can't switch the Everest config at certain times, no. But I would be really interested in the use case for that. For switching the config at a certain time. We planned that in for stuff like the firmware updates, so that when you're rolling out a new update, that you can set certain conditions, like only updating while the charger is not charging, or only at night or something like that. But switching between different configs is quite interesting as well. Feel free to send us your use case. Would be interested in what that is.
I mean, and to add to that, it's for us, the config is more, let's say, an ad hoc developing tool or emergency debug tool, or maybe commissioning tool when the electrician in the field is first setting up a charger. Let's say while operating a big fleet, config belongs to OCPP. So we don't want to
and I think we shouldn't confuse different kinds of configs here. We have obviously the whole big Everest YAML config, which the charger initially starts with. And in commissioning and those kind of situations, when you are out there in the field, you don't want to have the ability to change every value of that, because you are testing this config a lot, and you only want to give access to a certain subpart of that. That's also one of the features of CMC, that you can give different people access on different subparts of your configuration, so that, for example, an installer can only configure the OSPP URL, for example.
Yes, and as I said, we are not aiming for replacing OCP here anyhow. This is really for the debugging process before the charger goes out, and let's say for installations or for really weird emergency situations. Normally, the operational configurations adjustments belong to the CPO and CPMS. Okay, are there any other questions? Also, feel free to speak up or use the chat and or the Q&A tool. And or if not, I'm super happy to have you here today. And yeah, please ping us if you're interested or if you want to play with it. And also, if you're interested in software development in general, probably yes, otherwise you wouldn't be here. Please make sure you sign up for the event. It's basically free. We just have a really small fee to prevent no-shows and to pay for the food, but everything is sponsored, and except the talks, they're free. They're really selected by content and quality, not by how much people can pay to talk. Because we want to make it as useful as possible for developers. Yeah, looking forward to see you soon and have a great evening. Bye-bye.